Hi, today we're going to talk about water, but we're going to look at it from a little bit of a different perspective. So, we are aware that water is like kind of involved in liquids. And how does it involve itself in many types of liquids? Well, water is able to dissolve many different things. So this makes solutions, and solutions don't have to be with water, but that's one of the things that water does very well. It makes solutions, and solutions are the same throughout. They consist of a solvent. So see the word solvent here? And all these little gray circles are the solvent. And then the solvent surrounds the solute. So the solute gets dissolved by the solvent. The solvent does the dissolving. And the thing about a solution is it's the same throughout. So your powdered, Kool-Aid type drink or iced tea type drink, when you dump in the powder and you have the water is the solvent, and the powder that you dump in is the solute. You stir it up, you mix it up, and you get your drink, and that drink is a solution. We follow these rules when it comes to science that like dissolves like. So, what does that mean? Recall that water is a polar molecule. It has little areas that are charged and little areas that are not charged. And because of this, it only dissolves polar solutes. So, for example, in blood, we have polar proteins and sugars that get dissolved in water. Again, water is polar to form blood plasma. I know that seems kind of high tech, but we know that blood looks the same throughout. And that's because the stuff that's in blood gets dissolved by water. And then moving forward, we have nonpolar solvents that get dissolved, nonpolar solutes. So, for example, fats and oils can only be dissolved or broken down, and kind of mixed together with other things that are nonpolar, other fats and oils. So, for example, if you have something that's polar and you have something that's not polar and you try to mix them together, they don't mix together. So think like salad dressing. If you have some Italian salad dressing, there's always a part that's kind of like clear and then a part that's kind of like oily, separated out. And you can shake it up, shake it up, shake it up, shake it up, and it kind of mixes together. But then if it's left to settle again, those layers kind of form. And that follows this idea that oil and water don't mix. So when we're talking about additional application of water and solutions and solutes and solvents, we have this concept of acids and bases. And we measure an acid or a base using what's called the pH scale. And the pH scale is a numerical scale that measures, it gives a relative number to the concentration of hydrogen ions. So that sounds really complex, but I want you to think of concentration as amount. So something that's highly concentrated is like there's a lot of it. So if I'm making, again, back to my iced tea mix, and I put like 4 scoops of the powder in, that is going to create some strong iced tea. And that we would say that's a highly concentrated iced tea mix. Okay. So we're not talking about iced tea in terms of pH, but what we are talking about is hydrogen ions. So a hydrogen ion is an H plus ion. It has a positive charge, okay? So it's an ion in that it has a positive charge, and they're typically like hydrogen ions are kind of free floating. If there is a high or a large amount of hydrogen ions, this particular substance is acidic. Okay, so anything with a pH that's less than 7 in terms of a number. So we are talking about straight up like stomach acids here, things that have the word acid in it or are very acidic. Those would be considered to have a very low pH, a pH less than 7, and those substances have a high or a large amount of hydrogen ions or a high hydrogen ion concentration. When we look at bases, a base has a low hydrogen ion concentration. These substances have a large number in terms of pH value. And in that, we're looking at things like bile and bleach. Soaps can be kind of basic as well in terms of pH. So when we look at neutral, we're really looking at pure water, and that has a neutral solution has a value with a pH of 7. So I love this visual here at the bottom. This is showing you an acid. Sorry, my handwriting's not great with the mouse here, but lots of hydrogen ions here. This would be a low pH. Here is the pH of 7. And then here we've got like 13 or 14, and these would be bases. We're going to continue our study of acids and bases because in terms of applying it and this idea that we don't want, in terms of living things, big fluctuations in acids and bases, like changes in these hydrogen ions can really cause problems for living things. So we don't want there to be changes very quickly. So there are substances called buffers in living things that prevent like significant increases or significant decreases in hydrogen ion concentration. It can cause big problems for living things, but we'll talk about that more later on. Thanks so much.